All right, so I wanted to do an extremely impromptu live stream, really to just talk about how to choose a cloud solution and really to give you a little bit of context about this. I'm currently working on a little project with a friend of mine, and we thought it would be kind of cool to put together a little project that would get us working on a few different things. So we are working on a IoT, which is an Internet of Thing project, where we're basically collecting some sensor data and sending it up to the cloud, where we can process it, do some data analytics on it, maybe run it through some machine learning algorithms, some stuff like that, right? And I think it's useful sometimes to be able to do these kind of projects, to have a play around, really understand the different technologies, and just see what you can do, really. Now, if you're interested in any of these kind of things as well, then please do say hi and let me know what you would be interested in as well. And, I think there was quite a bit of research kind of put into deciding like how we would actually even go about this project in the first place. And so part of this video is really just kind of sharing some of those thoughts and findings so far. And really, I thought this was originally going to be a discussion with my friend. But I thought, well, hey, why not just jump on a live stream and just record this and share and get some of these thoughts out here as well, in case anybody else would be interested in that or could maybe even contribute to this as well. Because these days, I think there's a ton of benefits in moving to things like cloud. So, hey, Anthony, really good to see you there. So great to have you on board. It's great to be talking to a few people other than just myself. And the other reason I guess I'm here as well is to really actually spend a bit more time getting information out to all of you, instead of basically spending a lot of time just kind of researching a lot of things and putting together kind of different lectures and writing up different things that don't always get released. So I thought this would be, I got some really good advice to basically jump on live streams, to hash out ideas before trying to finalize them. So here we go. This is what I am doing on a Saturday night. So now here's a kind of basic agenda of some of the things I'm going to go over here. So actually, why use cloud? Like what is cloud even? I'm going to be talking a little about this project that I'm working on with my friend, which is basically an IoT cloud data science project. Talk a little bit about IoT devices, so little cool things like this kind of thing here, which can send all kinds of sensor data up to the cloud. Some cloud provider considerations, and a big part of this as well is going to be talking about the many options for databases and storage. So first up, why use cloud? Now you probably heard the term cloud quite a few times. And, cloud is effectively anything which is hosted up in the internet, right? But for the purpose of this talk, cloud, we're very much going to be talking about one of these providers here. So things like AWS, Microsoft Azure, Google Cloud Platform, and I've also got a couple of others down here as well, including DigitalOcean and Heroku, right? Now, in essence, whenever you want to develop an application, there's you normally need to store some data and have some sort of server to basically serve up those applications and stuff as well. So all of these different providers do that to some extent, and I'll go over some of the differences between what these how these different providers work. But effectively, so a lot of the times if you follow my channel, you'll probably be interested in data analytics and data science. And one of the things is when you're working on these kind of projects, there's either you're working on quite large data, in which case you want to be able to send some of those processes up to the cloud so that you can process larger amounts of data. And that would be probably using one of these three providers up the top here. These bottom two are less appropriate for that, and I'll go over why that is in a sec. And the other reason why you would want to use one of these different providers is basically that you might want to build some machine learning model and then actually turn that into an application or dashboard or something like that, which you then give to people so that you can actually get results into people's hands. So now let me see. So AWS is probably the most popular of all of these different services here. They're the most widely used right now. And so AWS has made huge strides in developing a lot of the cloud technologies. Now, just to give you, I guess, a bit of a spoiler, I mean, I do actually use, I guess, a combination of these different services. But in general, the one that I'm most interested in and excited about, especially from a data analytics, data science kind of perspective, is actually Microsoft Azure, right? Now, let me tell you a little bit about why, and not just data analytics, data science. The other thing is really a lot of times when you're moving into organizations, there's a very big shift that organizations are making on putting a lot of their work into the cloud. And I think of all of these services here, Microsoft Azure, I think, is probably going to be one of the most successful at this. And let me tell you a little bit about why. So effectively, cloud-based solutions, the benefits of cloud-based solutions is that traditionally, you used to set up physical hardware in servers. Like you actually had to go out and buy computers that would run 24/7, stick them in some big server room somewhere, set them up, install the software on them. And, this could take, especially in large organizations, this is something that would basically take often months sometimes to actually do, right? And I mean, a lot of that is to do with a lot of the process and logistics and the fact that you basically have to physically order hardware. But these days, it's much easier. So with any one of these services, you can jump online and you can spin up a server within a few minutes. So probably one of the number one key benefits of all of these services here is basically speed of implementation, right? Now, the kind of second main benefit of all of these services here is, well, sort of cost. Now, in some ways, it's much cheaper to use these services. Now, it's not always much cheaper to use these services, and we'll talk about that a little bit more in a sec as well. So, obviously, if a process normally takes several months and you can get it done in a few minutes as well, that's going to save a lot of time in terms of people resources, being able to, unlock bottlenecks and get your projects moving forward. So that's definitely one of the cost-saving aspects there. The other thing is because normally when you have to physically go out and buy hardware, you need to be able to cater for effectively your worst case scenario. And so you might be buying more hardware than what you actually need to buy. And then if it turns out that you don't necessarily need that hardware or something like that, then that can be very expensive also. Because sometimes, you work on projects and you don't necessarily know like how well it's going to work out, if it's going to work at all, how many users are going to come on board, all these kind of things. If all of a sudden you find out that your app is a massive hit and you're going out to like all of a sudden millions of users, then if you didn't buy enough hardware and you're hosting it yourself, then all of a sudden that fails and falls over. Now, that's one of the other great things about the cloud providers is that you're basically renting the service, and these things can scale up and scale out very, very quickly and easily. And you pay for what you use, as opposed to, like some fixed server, which may or may not be adequate for your needs or over adequate for your needs. So that's one of the ways that you can get a big cost saving there. Now, on the flip side of that, if you do know how much capacity that you actually need, and there's a very steady kind of state in your usage of one of these servers, then, well, actually, maybe you can actually go off and buy your own hardware and stuff like that instead. The other thing is that in a lot of large organizations, there is still a lot of resistance to moving things out to the cloud for various security reasons and different things like that, or more so the concerns about security, which, to be honest, in a lot of instances, these cloud providers are actually probably more secure than some of the on-prem solutions. But for a lot of organizations, you do need to have some on-prem solution to in place, especially for certain types of data. Now, that right there is probably one of the key benefits of Microsoft Azure. So AWS, so Amazon and Google, they're kind of, still fairly new companies which built all of their business in the cloud. And whereas Microsoft has been around for a lot longer, and so they have sold like software for physical servers and all this sort of thing, and so they have the best hybrid solution out of all of these different players here. They make it much easier to have these solutions which are part on-prem and part on cloud, and gradually migrate as you go. Which is one of the reasons why I think that a lot of organizations is just going to be a lot more practical to move to something like Microsoft Azure over the other players. Now, if you're a small organization, maybe you don't necessarily have these constraints. There is a number of other benefits that Microsoft Azure has as well. So even if you're not really strict about having data on-prem for whatever reason that is, sometimes having certain things on-prem is just cheaper, right? Because, so I'm working on this project with a friend. We are looking at sending sensor data from these kind of chips to store on some server somewhere. Now, if you can basically store this information locally on a local server before necessarily sending it up to a cloud-based server, that's actually going to be a lot cheaper because you're not paying for internet bandwidth, you're not paying for internet storage. You could have a relatively cheap server on site to be able to just collect data, right? So there are instances like that where, a hybrid solution does make sense. Now, coming back to, say data analytics, data science, those kind of things, Microsoft has a few other things as well, which I think are pretty good. So I got to read a research report once by a bunch of data scientists at an organization I was working with. And this was a fairly large organization, so we had quite a few data scientists at this working there. And they basically wrote up a report comparing the different cloud providers for the purpose of data science. And Microsoft Azure has the most data science services available. They've got the most kind of machine learning models that you can kind of pull out of the box and start using. I think it's like over 100 of them or so. So they had a lot more services from that perspective. A few other things which are quite handy as well. If you follow my channel, you probably know I'm a big fan of R programming, and of all the providers, Microsoft Azure has the best support for programming in R. So there's a kind of plus there. They've got their product Machine Learning Server as well as Machine Learning Studio, which actually provides some kind of drag and drop visual editor for making machine learning processes. Now, to be honest, I don't necessarily know that many data scientists which use the kind of drag and drop interfaces, but it is something that's there, especially if you're trying to democratize data science and get more people involved with that, right? Okay, so what else did I want to mention here? Now, with a lot of these services, some of the key components of it is basically compute and storage, right? So compute is, like running various applications. Probably the simplest service that these provide is something called a virtual machine. So that's basically when you have a computer that you set up, you can kind of, it's like a blank machine where you kind of install whatever you want on it, right? So VMs are probably the most common thing that people use when they first start using cloud-based services. Now, if all you're doing is VMs, by the way, then the cheapest provider is actually DigitalOcean. So that's why I've kind of popped them down here. They're actually about 3 times cheaper than, say, the 3 big cloud providers up the top there. So, something that you may want to think about and consider there if all you're doing is VMs. Now, I popped down Heroku down here as well. Now, these days, there's always like a lot of different products and terms and everything that kind of fly around. And sometimes you want like a quick update of like what kind of everything is and what it does and where it kind of fits in. So I thought I'd pop down Heroku down here as well. Heroku allows you to build effectively applications very kind of quickly and easily deploy them without having to set up too much stuff. So I popped down Heroku down here, although Heroku is really more for application development, and it's not really for virtual machines. It's not really for any of the machine learning stuff or data analytics or anything like that. So, but anyway, I thought I'd pop down that for anybody who's interested. Now, these days though, if you don't need to run a VM, like the thing is with a VM is that you need to effectively set up all of your own software on it, which is quite a bit of work in itself. Now, a lot of these providers have gone a step further by basically providing services that you can start using without having to install any software at all, without having to set up any servers at all. So these are usually called managed services. So if you want to set up a database, for example, you don't necessarily need to set up a VM and then install the database on top and then start using it there, right? You can just get a managed service, which is the database like right out of the box. So you can click straight through and skip a complete step, which is, well, it saves a lot of time in setup. It saves a lot of time in administration and stuff as well. And it enables you to scale up and scale down like much faster, much easier. So something to think about there. Now, DigitalOcean and Heroku only have very simple database types. So they have the more traditional relational databases. And this is something that we're going to go over in quite a bit more detail, because this is actually probably one of the key things I want to talk about actually, is the different ways that you can actually store your data, especially for data analytics, data science. Relational databases, although extremely common, a lot of people are very familiar with them. They're becoming much less relevant in these days, right? Because of what I'll show you later. Okay. Now, all these other providers up the top here, they have other types of storage. They have like data lake storage, blob storage. They also have a range of different databases. Now, if you've heard of things like NoSQL databases are the kind of the newer alternative to relational databases. And NoSQL is probably not even really the best name for these kind of databases, because it's SQL or SQL is actually a query language, not actually a database type at all. And some of the NoSQL databases actually use SQL to query them, right? So it's but they're all called NoSQL databases. And anyway, but what is kind of the key distinction between a traditional relational database and a NoSQL database? Well, first of all, a lot of the NoSQL databases, they use different structures, and they're what's known as schema lists. So with traditional relational databases, it was very strict about the way that you'd structure and organize your data. And if you were building an application and you were working through and found out partway that you needed to add like an additional field or something like that, or you end up with some sort of one-to-many relationship or something like that, which wasn't implemented in the initial specification of the database, that could be a ton of work to go back and re-implement that. And that could be, like a real pain. Whereas with NoSQL databases, that is much, much, much easier to get in place. So the other benefits of NoSQL databases as well over traditional relational databases is that it's this whole thing about scale and stuff as well. Now, as mentioned, one of the reasons why you kind of move your data to the cloud in the first place is because of scale, right? Because you've done some analysis, you've done some work, and you want more than one person to use it. You don't want it to be something just sitting on your computer. You want to be able to potentially service out to thousands or, potentially even millions of people. And now, in order to do that, you need to be able to usually spread these applications and data over multiple computers. And these multiple computers can reside in different locations, in different data centers all around the world, right? So this is a concept known as sort of availability zones. So this is one of the kind of key concepts in cloud, that you can take your data and kind of spread it all over the place. So, for instance, if you're in Australia, then, ideally you want to be accessing a server which is based in Australia. Whereas if you have a user using the same application who's based in London, then you want them to be pulling that off a local server instead. So, hey, Bexley Mike, thanks for joining. Thanks for staying high. Also, if you're joining, just do take the chance to introduce yourself and let me know what you're interested in this particular talk. So I've been going over a few things so far, but generally talking about, basically cloud, IoT. I'm going to be talking about data structures, and all of this is kind of based around like a little project that I'm working on with a friend at the moment. So just to give you a little bit of background there. All right, so where was I? So I was talking about how, we want applications to be distributed. We also want the data to be distributed as well. And the thing is with traditional relational databases is that they just don't spread out very well, right? So whenever you want to scale up a relational database, usually you get one computer and you make that more powerful. Now, these days on the internet, nothing works like that anymore, right? Everything is usually spread across multiple computers, and you need the sort of background infrastructure to be able to support that. And pretty much all of the NoSQL databases do. So let me just check this question here. So I'm curious if you have ever tried something like Ansible server as your own cloud. Do you know of any good resources on helping to set up your own cloud on something like Ansible? Sorry, I haven't actually heard of Ansible. So if you could give a little bit more details about what that is, that'd be awesome. Because I'm always interested in what other people are using for different things. There's one of the things in this field is when you're working in technology, there's just so many different options available. There's a lot of times, you just don't know what a lot of different things are. I mean, I go off and I talk to my tech friends and different things like that. And, with all the new technologies coming in, and then basically every single vendor basically having a different name for the same technology, it becomes really, really hard to kind of keep on top of everything. So, so if you give me a little bit more details about that, I'd love to chat with you about it. Okay. So, let me head over here. So I'm just wondering if I've answered the question, why use cloud? So basically, it scales. It's super fast to set up. And for a lot of situations, it's cheaper. So that's kind of that. So a little bit about this project that I am working on at the moment. So as mentioned earlier, I'm working on a friend on this kind of IoT cloud data science project where we're basically looking at collecting some data from like a little chip like this and setting it up to cloud so that we can start doing some processing on it. So I think this could be interesting. I mean, this basically collects, this is called an MX chip. And actually originally did a little workshop here in London. This was hosted by Linux for London. They're like an awesome meetup group, actually, if you are from around here. And they run a whole ton of different things on cloud and Linux and IoT devices, all kinds of things. And there was this workshop which was run by Jim Bennet from Microsoft. And there's actually a link to his GitHub repo where he's got this project. Let me just bring it up here as well. So this little workshop here where you basically spent an evening like putting this thing together. So it was pretty cool. Spend a few hours and then you can set this up and do this whole project. But I thought I'd take the chance to kind of do it again, kind of really take the time to understand all the different components of it, build it out a little bit more, see what kind of data analytics and stuff that you could do on it also. So anyway, if you want to check that out, there is a link in the description as well. Okay, so now a little chat about IoT devices. Okay, so just reading your questions here. So Ansible is an inexpensive server one can use at home, but it's not as easy as I was thinking. So is that like is it hardware or software? Actually, let me just Google this. So. Okay. So I was curious about what these different things are here. So it's a private cloud. Okay. So you're interested in setting up your own server and you want to use it in place of DigitalOcean. So, I mean, yeah, I mean, the easiest way to set up a Shiny server is using, like Shiny Apps .io is probably the easiest way. DigitalOcean is probably the cheapest provider of VMs I've seen, which is, I guess, a way of setting this up. I mean, okay, so you got this little thing here. So I'm curious actually how this differs from, like, I don't know, like any other computer that you'd set up in your house actually. Because yeah, I mean, I guess you could always run your own kind of Linux box or something like that. I got some friends actually who actually even they set up an R server on a Raspberry Pi, which is pretty interesting. I thought it'd probably be a little bit underpowered to be able to do something like that, but an interesting concept nonetheless. So. Yeah, we'll have to have a look into that. Cool. No, I was always happy to get some feedback from different people. If this, it's always nice to have a little bit of a conversation and stuff as well. So it's not just me talking here. I think there's always a lot of valuable information that comes from, like, all the different people working on these kind of things. So anyway, thanks for leaving some of those comments there. All right. So anyway, where was I? Yeah, so I was talking about this little project that I was working on. Yeah, I popped down IoT devices in here just because I thought this was something quite interesting to talk about as well. Just because, yeah, I realized that there's I mean, I actually ended up spending quite a bit of time, like, looking into all these kind of things, and there's actually quite a bit of information available. So probably one of the most common devices that you will see for, like, IoT is Raspberry Pis. So Raspberry Pis are very, very common kind of devices. You can run Linux, you can basically run a full operating system on them, plug in like a monitor and keyboard, and away you go. They can run Python, and you can connect up all different types of things to them as well. Now, the other kind of really key IoT device that you probably see around is Arduino. So Arduino is really interesting actually. They're an Italian company which actually open sourced hardware specifications. So they basically designed this little microcontroller, which, yeah, it's an open source specification so that lots and lots and lots of different manufacturers can effectively make this exact same board. So if you jump on Amazon and you type in Arduino and look up Arduino controllers and stuff, then you'll see a ton of controllers which basically say that they are Arduino compatible, or something like that, and that's because lots of manufacturers can build them to that exact same specification. Now, Arduino is interesting because they're generally much cheaper devices. Some of them you can pick them up for even like a couple of pounds, so very, very cheap to be able to get hold of these devices. So I mean, compared to a Raspberry Pi, I think it's like about 20 pounds or something like that. Whereas Arduino you can pick up for potentially some of the units, and they have actually quite a few different ones. You can pick up for a couple of pounds. And so these things, if you're thinking about what you actually want to roll out to production or something like that, then maybe that's what you want instead. And these are much lower power devices than your typical Raspberry Pis. They use much less, they have much less processing power. So you're not going to be able to run something like Python or something like that on an Arduino device. They're good for things like picking up, say, sensor data is probably one of the big uses for them. So microcontrollers for like robots and different things like that. Basic logic gateways, you're not really going to be running you're not going to be deploying a machine learning model on a Arduino device, right? Probably, right? But basically basic logic controls and sending sensor data is a good use for that. Now, what I found really interesting as well was basically this device. So this is called an NX chip, right? So that was in the link that I shared with you guys before. And this is an Arduino compatible developer board, right? So one of the things with Arduino is that it's extremely bare bones. Any sensors that you want to add to it, you basically have to solder them on, right? So they're quite involved that way. Like some of them you even need to solder on a power source and all this kind of thing as well. So a bit more kind of work and effort kind of involved there. You have to actually go out and buy the sensors, connect them. This particular board here is an Arduino compatible board, but it's got like a lot of the sensors already built in. So here we have things like an accelerometer, gyroscope, humidity, temperature, pressure, a magnetometer. It's already got things like Wi-Fi on here. It's got like a little mini display, which is handy for diagnosing things, like a couple of buttons, headphone jack, mic. So, and these are automatically set up actually to, work with Azure and stuff as well. So nice little thing there if you're building like a little cloud internet device. Right. But yeah, then when you want, but these things here, this is probably about, this is like 40 pounds or so. So once you actually want to go to deploy an actual solution, then probably you want to go to something like, like a plain Arduino device instead. So anyway, I thought that was kind of interesting. So I thought I'd share a few things there. Now, let's go into this kind of next point here, cloud provider considerations. So actually, I did talk a bit about this already. Effectively, which cloud provider that you choose depends a lot on the type of thing that you're going to do. So coming back to this list here, like these top three kind of providers up the top, they'll have things like machine learning algorithms and everything, kind of pre-built machine learning models and everything like that you can effectively tap into. If you need to do any heavy processing, you can kind of do that all in the cloud with these three providers up here. They have like a lot more database options, which we will talk about in a sec, compared to these ones, which really only have relational database solutions. And as mentioned, Azure has a lot more machine learning options than actually these other two here. AWS is interesting actually. In fact, Azure, one of the things I was really surprised about is that if you are actually interested in setting up a relational database, then there's a good chance you might actually want to go with one of these other providers instead of Azure. So even though, like I mentioned, that Azure is probably the main cloud provider that I'm kind of looking into, but if I was to set up a relational database, their kind of key option is SQL Server, which is not the right option, but it's actually quite expensive. Like it's almost like Microsoft wants to push you towards the NoSQL options. So they've got CosmoDB, which is just quite nice actually. So when we go into the kind of database storage solutions and stuff, one of the things that you'll see and realize is that there's actually a lot of different solutions, and this is one of the things that kind of makes things a little bit more complicated as well. So with there's you've got document databases like MongoDB is like a really popular one there. You've got Columnstore databases like Cassandra, which is a really popular option. You've got graph databases like Neo4j. And there's a ton of different database options available. Now, AWS was really good about providing a lot of these different database types. That was one of their kind of big things when they were coming out. Now with Azure, one of the things that they did really nice is they basically just packed them all into one, right? They basically said, yeah, instead of releasing like a separate NoSQL database for every single data type, like data. What do you call it? Data model type. Then they basically just kind of all rolled it into one. So Cosmos is a multi-model database, which effectively enables any of the NoSQL database types. So instead of having to pay for multiple services, you pay for one, and then you can experiment with lots of different things. So that's actually a quite nice feature of Microsoft Azure Cosmos database. And as mentioned, surprisingly seemed to be much cheaper than their kind of SQL Server solution. Whereas like all of these other providers, the relational database solution are just much cheaper than the Azure solution, which I thought was interesting. Also, if you are say using like Oracle or something like that, Amazon's actually gone off and developed a product which is effectively Oracle compatible, so you can shift your Oracle databases and migrate them over to AWS and save lots of money that way, right? So if you have something like that, then maybe AWS could be a good option for you, right? Okay. Cool. So yeah, good to see some people have been already using like Arduinos and Raspberry Pis. Yeah, gotta get into them a little bit more myself. I think yeah, some good fun to play with all these kind of bits and pieces. So okay. Okay. So as mentioned, I was working on this project with my friend, and one of the things we wanted to go away and do is basically figure out, okay, what would be the most logical, sensible way to actually collect and store the data so that we could later on analyze it And I mentioned before that there was this GitHub project that I was kind of following to get this done originally. And what they had done is they decided to use a document database model. Now, for those of you who aren't familiar with a document database model, this is a very kind of flexible kind of structure. So MongoDB, again, is like probably the number one primary document database. And generally speaking, document databases are becoming very, very popular with application developers because of the fact that not everything's necessarily in the schema, you can kind of add stuff like really, really easy without having to completely rewrite and rebuild your database, right? So I've got some developer friends, they're doing some stuff and they are using, they're using Cosmos document database to build the applications just because it's so much easier to iterate and change stuff. It's also, it also scales very, very well. Document databases have got, are very efficient at transactions and flexible schemas. Now, here's an upside and a downside of that. So document databases, they're not like your traditional table structure. They have they can have things like nested structures, right? Now, this is very handy for development when maybe that kind of structure more closely fits your actual application. But from a data analyst point of view, this can sometimes be a bit of a pain in the ass, to be honest, right? Because effectively you have to go through and you have to start unnesting these structures. You have to effectively dig through these structures to extract your data into maybe, basically a data frame or something like that, right? So working with document databases can be quite a bit of work sometimes. Now, it doesn't necessarily have to be, because again, it depends like how much kind of nesting and everything like that is involved in the document database. Because there's basically a bunch of functions and libraries which will flatten those out. But if there's a lot of nesting, it can still be a pain in the ass to work with. Now, aside from document databases, you have other data structures. So like Columnstore databases, like Cassandra. That's also a model that's included here as well. Columnstore, yeah, basically it's a more traditional table structure. This is more like a data frame. Very fast for reading and writing data. Now, if you are working with something like Cassandra, you probably still want to potentially still replicate that over to some sort of other data store like Spark or something like that, which will give you faster analytics processing on that data. So a few things to consider there. Now, the thing is with database options is that they're still actually relatively expensive compared to things like data lake or blob storage. So these days you have things like basically all the cloud providers have some sort of blob storage, right? Now, what is blob storage exactly? So if you've heard of things like Hadoop, one of the big things about Hadoop was built on. Hadoop's a bit confusing in a way because it's actually not one technology. It's like its own little technology stack, right? But one of the kind of corners of Hadoop is something known as HDFS, which effectively is a distributed file system. So these days people don't usually work too much with kind of Hadoop directly. And now, again, it depends on what you're talking about or what you're referring to when you talk about Hadoop. But Hadoop usually means is usually referring to using an on-prem Hadoop technology stack, whereas these days you wouldn't use things like HDFS because all the cloud providers have their own blob storage, which is much cheaper and easier to set up. So collecting the data. So I mean because effectively my friend and I were effectively pulling out our credit cards and paying for this ourselves. To get some databases up and running just to have a bit of a play around with. You kind of want to make it as cheap as possible. And to be honest, like even if you had some budget to do this, if you're going to scale it up or scale it out or different things like that, you still want to think about how you would go about doing this in a cost-effective way. But, I guess not just the cost-effective way. You want to be able to be doing this in a fairly efficient way as well. Right. So what are the different trade-offs? And this is like the big thing these days is that it's in a way there's a lot more options. There's like, I don't know, nearly half a dozen different database types, right? And it's all about engineering trade-offs that you get between switching between all the different options, all the different options available. Now, to give you a little bit of a sense, now Cosmos DB, it's not terribly expensive. I think maybe it would cost you starting from about £20 a month to get a database up and running, which is, this is kind of not too bad. But if you were to kind of switch over to something like a data lake storage instead, that would be like 9 cents per month, right? So much cheaper than the database option. Now, obviously with the database, you're getting a little bit more structure to it. And you have the ability to, I guess in a way, more efficiently query that and query that faster. The interesting thing is that these days, even with data lake storage, it's which is almost basically just a bunch of files, it's still possible to use things like SQL and different query languages in order to query that. So Amazon AWS has got things like Athena, which you can use to query those things. So with Microsoft Azure, you can either use something like Hive, which is a SQL-like query language developed by Facebook for querying that kind of stuff. They also have something as well called USQL, which again, I think it's Microsoft's own implementation or something like that, which is a combination of a SQL-like language. Now, here's the thing with SQL as well. SQL was basically designed for querying tables, right? And relational databases. And so when you move to some of the other kind of non-relational database structures, then it's then you need different types of query languages for doing that. I mean, effectively, MongoDB has its own kind of query language for querying document databases. There's various different query languages for querying graph type structures, like Neo4j has their own query language Cypher. A few of the other kind of key ones are Gremlin and Tinkerpop, right, for querying graph data structures. Yeah, so that's a great question. So there's a question. Do these solutions allow one to increase and decrease the amount of storage used so that we're only paying for what we need at the time? And yeah, that's probably one of the key benefits of cloud, is that it's fairly easy to scale your requirements up and down based on what you actually need. So yeah, that's definitely one of the benefits. One of the benefits there. Talking about scaling, actually, one thing that's interesting to talk about is that when you are using cloud, there's actually a few different options available. Now, and it's one of the things that can actually make these things really confusing, because you jump into something like AWS or Azure, and there's like literally hundreds of product offerings all wrapped up within that one service. And you have the kind of older, more traditional things like VMs and stuff like that. And VMs are much harder to scale up and down, right? Because effectively you're buying a computer which has a certain specification. Maybe you're buying it with actually the storage is kind of separate, but sometimes you're buying this with like a fixed amount of processing and RAM and all this kind of stuff like that. And although it is possible to turn it off and on, like it is relatively easy to do that compared to a traditional computer. And it is possible to basically take an image of that server, turn that one off, load up another computer and kind of load that image on if the maybe the processor or RAM, whatever, was not enough for your requirements. It is possible to do that, but it's not the most efficient way to do that anymore. The big thing that a lot of these providers are trying to move everybody towards to is something called serverless computing. Now, I don't know if any of you guys know what serverless computing is, but effectively this is a way that will automatically scale your sort of processing and memory requirements for what you need to do. So these work, I think, particularly well for very unpredictable workloads, workloads that can spike very, very quickly and go from, say, 0 to like 1 million. These can work really well. And it basically just spins up all the resources that you need only when you need them, right? So there's something quite cool there. Okay. So anyway, where was I? Yeah, so databases and storage. Yeah, this is interesting. So as mentioned, yeah, there's quite a few different options to choose from. Potentially, if we went for like a data lake solution, it would be extremely cheap, but then a bit slower to retrieve that data. Now, this is an interesting one actually, because given the amount of data that we are looking at for our particular proof of concept, then this could actually be, like the processing time would probably be negligible anyway. And so it probably wouldn't really matter if we went to a sort of data lake solution. Now, on the flip side to that, let's say that you did have like a massive amount of data. So like if you wanted to take your data and store it in raw format. So if you didn't want to like enter it into some sort of scheme or some database or anything like that. Now, if you were actually, depending on the granularity of the data. Now, one of the cool things about these devices and being able to add everything to the cloud and everything like that is that you can potentially scale out to like billions of devices, and you can basically manage billions of devices from the cloud. You can basically administer these kind of things, like send updates to them, deploy kind of software and all these to like billions of devices with a few clicks. Once you kind of had these things in place. And so potentially you could be collecting a lot of data through an IoT device. And in those kind of situations, maybe you still do want to have just a sort of data lake solution, because it's just so much cheaper for actually collecting data. And perhaps what you actually want to use for analysis purposes is actually on a very, very small subset of that. And so it probably makes sense to capture all of the data that's coming from the sensors in a data lake, extract what you need, and replicate that to an analysis server like Spark or something like that for actual analysis work. But a few more kind of layers involved in that as well. It's not a direct database, basically, right? And so that's probably the solution on thinking about doing at the moment. The document database, as mentioned, that was already part of the GitHub repo, so that was already part of this project. And again, maybe something interesting to work with and know, because a lot of developers use it these days. I think document databases are probably going to be the key type of database that applications will be built with these days. But as mentioned, document databases can be a pain in the ass for analysis work, which is why maybe it would want to capture stuff natively in a Columnstore database like Cassandra or something like that. But I don't know, it doesn't seem to be as popular as something like Mongo. I guess it's not as flexible for developers. Or I could just capture the files in the data lake. So a few different options there and things to think about. Okay. So it's great information. We're not dealing with just VMs, but more like mass storage for use on-site computing machines. Is this correct? Yeah, I mean, there's a ton more to cloud computing than VMs. VMs is probably the most basic service, and it's the easiest for people to understand and get started with. But effectively, all the cloud computing providers have broken these things down into like smaller and smaller and smaller components, so that you can just that's why there are so many services. That's why there are hundreds of services. VMs are almost like the kind of catch-all easy thing to do. So I mean, particularly, so I mean, you mentioned earlier that you're using something like some stuff like R. I mean, I've set up my own R servers and stuff like that as well using VMs because, well, unfortunately you can't, these aren't kind of software as a service kind of solutions. So, you would use VMs in those type of situations. But a lot of these providers, they're basically trying to almost create all of the building blocks for doing analysis work, building applications, building out IT infrastructure. So, you're looking at database solutions. They're getting very, very granular, right? You've got, like half a dozen solutions just for databases and storage, right? Like all the things I mentioned already. When you're going into machine learning models, they've got like all of these kind of off-the-shelf different machine learning models, which are all, just there. You just kind of pluck them off the shelf. And kind of by building these kind of ecosystems and everything, I guess they do start to kind of tie you into their services and stuff in a way. But there is like a really good use case for these kind of things as well. Basically, nothing kind of scales as well and as easily as using one of these kinds of services. So, there's something to think about there. Like if you are setting up something like your own R servers, even though like I think like an R server could pretty easily handle maybe a few thousand users or something like that, but it's still not going to be as scalable. So I mean, I love R like a lot, basically because like if you've done any of my courses or anything like that, you can see that if you're an analyst, right, and that's your primary role, you want to like get on the data, do a bit of work with it, and turn it into some application. This can be like quite involved with some of these other services, right? So this is something interesting, actually. I mean, when you look at the kind of Python, typical ways of working with Python and kind of the technology stacks and the way that you kind of work within it, it's usually there's a lot of different people involved in the process. Like, once the analysis is done in like a notebook or something like that, then it's usually rewritten completely by an IT developer team to turn into some application. Whereas with R, you can do everything from beginning to end, like ridiculously quickly. Like I honestly think that you can basically get minimum viable products, proof of concepts, or dashboards, data applications out probably 10 times faster in R than pretty much like anything else that I've seen. So, yeah, cool. Yeah, no, like R is just kind of awesome for that kind of stuff. But sometimes, I know there's like a lot of data scientists and who they do need like more kind of computing power. I was recently at a London R meetup, and there was a great talk by one of the guys who was basically pushing jobs to AWS. It was basically using his own AWS, like supercomputer, because certain types of jobs just do take a lot of processing. Now, how much data do you actually need to do that? I mean, obviously, there's guys who work with tons and tons and tons of data, and that almost becomes like a skill and expertise in itself. I think to almost figure out not just how to like implement your model, but how to actually implement your model in a way like by spreading it across multiple computers and all this kind of stuff like that, so that it will even run, right? So I think that's a pretty interesting thing in itself. I think obviously there's like I saw this video a little while ago saying it's like, oh well, like 80% of the data basically runs on Excel spreadsheets and stuff like that. And so anything that kind of runs on like an Excel spreadsheet, and it's like, well, yeah, you're not really worried about supercomputing or anything at all. You just shift over to R, and that's going to like run a million times faster, like out of the box on the laptop, right? But there is definitely this other kind of world as well, where either you want to process more data, or you want to get your applications in front of more people. So yeah, I mean, things like Shiny and Flex dashboards and like some of the stuff that I teach, I think is definitely one of the easiest ways of doing that. I think once you start getting into and start exploring things like cloud, and it's like, okay, well, where do I set up my Shiny server if I don't want to just use Shiny apps.io? You start looking into things like AWS and Azure and seeing all the different things that are available. Well, actually, if you want to get a server up and running, it's like, well, you probably want a database as well, right? And then, what are your kind of options for a database for actually storing your stuff, right? So AWS or Azure is like a really good option for that, right? It's interesting actually. Azure is got the best support for R of all the different cloud providers. But I don't know, maybe I'll have to go over this another time, but they almost have they have a very different way of implementing things. So I would say the R Studio stack, if you want to call it that, is just unbelievably efficient for analysts, and has like very decent scale. But again, these are not these aren't kind of multi computer clusters or anything like that. Like if you want a more powerful R server, you effectively have to get like a more powerful machine. Whereas some of these other things are just much easier to scale if you're up to a certain level, right? So anyway, I think I've been sort of going on for a bit about this. Good just to have a chat, really get some of these kind of thoughts out of my head. Hopefully this has been kind of helpful to people out there. If you have any questions or thoughts that you want to share, please do leave a comment either in chat, or I don't know, if you're kind of watching this later, just leave a comment below and stuff as well. And I hope to be doing a few more live streams. I'm going to be away for the next week or so, but I want to get to I'm working on a another course for teaching some data analytics in R, just getting everybody up to the latest standards and everything like that, because I think that there's still a lot of training going around, which is based on, well, maybe how you'd use R like 10 years ago, and that's massively changed. And so, just having some of the information about, like all of that, I think can really show people how much easier it can be these days, and easier, not just compared to what it used to be, but how much easier it can be than a lot of the other solutions around as well. So anyway, hopefully you found that helpful, and I will talk to you guys later.